Solving systems of linear inequalities. In our first example, we have y is bigger than x plus 3. Now I want us to recall that when we just have one inequality, we've done this before. There's a rule, and the rule says that when I have y is larger than a function of x, in this case, then we're going to be shading upward. And we'll see what that looks like. Just sort of a quick example here. So if we have a line and its y is larger than, then we shade above the line. The opposite happens if its y is less than or equal to, of course. We're going to shade downward. Some teachers have you test a point. You can also apply that here as well. And what that would look like, the shade downward, would be here. Like this. So back up to our example. Y is bigger than x plus 3. Notice it's already in slope-intercept form, which we very much like. So what I want to do is write down the slope, in this case is 1, or 1 over 1. The y-intercept, b in this case, is 3. So we're going to start graphing the line, and we're going to start at y equals 3, because that's the y-intercept, that's b, a little dot there. The slope is 1 over 1, so we're going to rise 1 and run 1 and put a little dot there. Now notice that y is strictly bigger than. That means we are going to have a dotted line, because we are not going to include the line y equals x plus 3 in this case. So we're going to have a nice dotted line. Now, according to the rule that we just mentioned down below, when its y is bigger than, that means that we are going to shade upward. So the graph is going to be like this. The line y equals x plus 3 is the border, and we're not including it because we have the shaded. Now the example just to the right of this is similar, except now its y is less than x plus 3. So we're going to graph the same line. It also is going to be dotted in this case. I'm going to rise 1, run 1 to my next point. And again, I'm going to draw a dotted line. Indicating that it is strictly less than. Now, because it's less than, according to the rule down below, we're going to shade downward now. Meaning every point underneath this line is a solution to this line here. We're going to skip down past the rules, down to two inequalities that are basically lines. The top one, y is less than negative 1/2 x plus 2. We have a y-intercept of 2 and a slope of negative 1/2. Now notice that it's strictly less than. The one below it is y is larger than and equal to. So we're going to have a solid line with that one, with a y-intercept of negative 4 and 1. We're going to start out by graphing the first line. Y is less than negative 1/2 x plus 2. So we're going to start again at 2. In this case, I have a negative slope, so I'm going to go downward and then to the right, 2 spaces. Some teachers may have you go up and to the left. Both are correct. This particular line is going to be a dotted line because y is strictly less than. So we are not including this as a boundary. Now, I'm not going to shade yet. We'll get to that. I'm going to graph the other line, which has a y-intercept of negative 4. So I'm going to start down here at negative 4. The slope is 1. I'm going to rise 1 and run 1. Now this is y is bigger than or equal to. So I'm actually going to have a solid line now to represent the boundary in this case, because we are including the line y equals x minus 4. Now I want to take a look at the top line, and its y is less than. That means I'm going to shade downward. I'm going to very lightly I'm going to show that we're shading downward all over, all the way down. The other one is y is bigger than, so it is going to be going upward relative to that line. Now I'm only interested in the spot where both are shaded, so my actual region that I'm interested in is right here. Only here. Only between these two lines all the way until they intersect right here. So here is my solution set. Now I know it looks messy, but that's definitely the solution set. Let's try another example. This next example, I have 2x minus y is less than or equal to 4. I'm going to call that equation A. And 3x plus 2y is bigger than 6. That's going to be my B inequality. I'm going to take the first inequality, A, which is the 2x minus y is less than or equal to 4. And I'm going to put it in the slope-intercept form so I can use the rules that I did on the previous page. So to get y by itself, I'm going to subtract 2x to both sides. I'm left with negative y, be careful with that negative, is less than or equal to negative 2x plus 4. Now, I'm going to have to divide by negative 1 in this case, which means I have to be really, really careful. Because when I divide by a negative with an inequality, if you remember, all the signs switch. This gives me y is now bigger than or equal to 2x minus 4. So be careful with that inequality. So this is still equation or inequality A. We're going to do the same for inequality B, and then we will graph them. So I'm going to start with 3x plus 2y is bigger than 6. I'm going to subtract the 3x. 2y is bigger than negative 3x plus 6. And I'm going to divide through by 2. So y is bigger than, I don't need to switch the sign because I'm dividing by a positive value. Negative 3 halves x plus 3. And that's my equation B. I'm going to go ahead and graph equation A. I'm going to start at when y equals negative 4. And that's my y-intercept. And the slope is 2, so I'm going to rise 2 and run 1 to the right. Now, because it's bigger than or equal to, this will be a solid line. That's my equation A. Okay. Equation B is going to start up at positive 3. And the slope is a negative 3 halves, so I'm going to go down 3 and to the right 2 spaces. This is going to be a dotted line because it is y is strictly bigger than and not equal to. Now for the shading. The first equation, equation A, is bigger than or equal to. So I'm actually going to shade above the line. The other equation is also bigger than, so it's going to be above the line as well. And what I need to do is find where the two shaded regions intersect, and that's going to be this top region here. So we're going to end up with this entire region here is going to be the region of interest. So all the points in that region is a solution set to this system of linear inequalities. Our last problem, if you remember, y equals a number is a horizontal line and x equals a number is a vertical line. So I have y is bigger than negative 1, so I'm going to go where y equals negative 1. In this case, I'm going to have a dotted line. And x is less than or equal to positive 4. So I'm actually going to go to x equals 4, and I'm going to have a vertical line at at 4. It's going to be solid because of the equal to symbol. Now, where y is bigger than -1, that's going to be shading upward. Where x is less than or equal to 4, it's going to be to the left. So where they intersect is going to be this top left